Good afternoon, everyone. My name is Franco Montalto from Drexel University and CC Run, the Consortium for Climate Risks in the Urban Northeast. And we are happy to welcome you to the May 2021 edition of Green Infrastructure, Climate and Cities, brought to you by CC Run, together with the partners shown at the bottom of this screen. For those of you who have not joined us before, we've been doing this seminar series back since 2014 on the first Wednesday of every month. Since the pandemic began, we've been doing them through Zoom. All of our previous presentations are archived on the ccrun.org website, so feel free to go to CC Run and check out any of the previous talks that we've hosted through this series. Throughout the series, just some general notes. You can use the Q&A button or box to submit questions. Don't use the chat. The chat is solely for comments. If you're having problems, one of the speakers can't hear them, that kind of a thing. But otherwise, questions for the speakers you can submit through the Q&A box. You can also upvote comments that have been submitted by others, and you can raise your hand to ask a question verbally. And if we have time at the end, we can move into that kind of back and forth. I also want to begin with an announcement just for our Philadelphia friends and partners. Drexel, together with the city of Philadelphia and the other partners shown at the bottom of the screen here, is developing a resilience research agenda for the Philadelphia region. And if you have not seen it yet, there is a call for nominations. You can self-nominate or nominate someone else to be either a member or a co-lead of 4 working groups that will be working on to develop a research agenda for Philadelphia region over the summer. And you can see the 4 working groups listed here. The first one focusing on climate change and cascading hazards, the second one focusing on vulnerability, the third focusing on the climate governance, and the fourth focusing on the built environment. So if you're interested in being part of this program, please look out for the Climate Resilience Research Agenda, a name in the ring. So this is the second of a 3-part series within a CC1 series that is focusing on resources, tools, and methods for preparing for climate change. So our first edition of the series was in March, and this is the second, and then the third is next month. And I'll introduce our speakers in a moment. But before I do that, we begin the series with this Lenape land acknowledgement, just acknowledging that many of the communities that are within the CC Run regional area are on the historical homeland of the Lenape Native Americans. And we hope that through these discussions, like all the discussions precipitated by this series and related series, that we will inspire the dialogue that's needed to better care for this land and to respect it the way it has been by Indigenous communities in the past. So that's our acknowledgement. With that, I want to introduce our 2 speakers, Art DeGaetano and Jessica Spaccio. Both of them are from the Northeast Regional Climate Center, and they'll explain what that is in a moment. But just in case you haven't heard of that, there's a series of 6 regional climate centers managed by NOAA that provide climate data to users around the country. And so Art and Jessica manage the Northeast Regional Climate Center, which includes the Philadelphia region. So Jessica will be our first presenter, and she's a climatologist with NRCC based at Cornell University, excuse me. And she's also an alumnus of Cornell's Earth and Atmospheric Sciences program. And after Jessica gives her portion of the presentation, Art DeGaetano will go next. He's a professor in the Department of Earth and Atmospheric Sciences at Cornell, and is also the director of NRCC. And for those of you who publish, he's an editor of the American Meteorological Society and the Journal of Applied Meteorology and Climatology. So with that, I will stop sharing. And Jessica, if you want to start sharing. Great. Take it away.
Sounds good. And we're gonna mess up Franco right from the start, where I'm going to give a couple of introductory remarks. Jessica, you can move on. So kind of a brief overview of what the Regional Climate Center program is, and specifically the Northeast Regional Climate Center. Kind of a combination here. And I think the little graphic to the right really sums it up. What we're designed to do is take data, big data sets, and turn it into useful information for our stakeholders across the region. And I think through the course of this webinar, both Jess and I will hopefully give you a flavor for the different ways that we do that. If you look at the map to the left, kind of shows the breakup of the 6 centers. Like Franco said, there are 6 regional climate centers scattered across the country. The Northeast covers the states from Maine down to West Virginia, with Virginia excluded. But I should mention 2 things about this map, even though kind of the states are colored in different areas to correspond to our regions of interest. We are definitely a national program, and in a lot of cases, we don't necessarily respect the boundaries. We basically work with each other to share our resources, share our tools, share our data sets among the 6 centers. The other thing that I should mention is, like the RESAs, the regional climate centers are a competed program within NOAA, and we just completed our recompete. The dot will stay in Ithaca, New York at Cornell for the Northeast, but a couple of the other dots will change, particularly in the central part of the country. The LSU Center is moving to Texas A&M, so Texas will cover the South, and there will be also some movement in the Midwest. So basically, if we look at the bottom of the screen, I think the 4 bullets kind of summarize the types of things that we'll do, and kind of really the things that characterize both the NRCC and the Regional Climate Center program. Really, the first thing what NOAA has really designed us to do is basically make their data more useful to people. As I think many people know, they maintain and archive lots of big data sets. But in a lot of cases, you need to be a data scientist to actually extract the data that you need and extract the information that you need. And basically, we do that through a number of things: webinars, computer-based tools, APIs into the database that kind of tie the data with software, things along those lines. In the second bullet, one of our big roles is monitoring regional climate conditions. Jessica will give you some examples of how we monitor drought and changes in temperature. Clearly, the last couple of days, our big thing has been the release of the new normals by NOAA. So basically, a lot of day-to-day type operational things in looking at the regional monitoring. We integrate. We don't really do a lot of stuff on our own. We partner with lots of different folks across federal agencies, particularly the Weather Service and USDA, with the state climatologists in each of the states that have them, interactions with the RESAs, and you name it, basically. So we'll see how that integration with other agencies really promotes our data dissemination tasks. And then finally, at the end, kind of as a fringe benefit, and the fact that we are at a regional at a research university, there is a more of an applied as opposed to a basic research component to a lot of our tools and data sets. You can go on, Jess. Just kind of a brief history. The RCCs have been around for really a long time. Got their start way back in the late 1970s as part of the National Climate Program Act. That's the legislation that actually authorizes the existence of the climate centers. The center here at Cornell was one of the earliest RCCs. It was actually a demonstration project in the early 1980s, and kind of incidentally, kind of going full circle, my PhD research at Rutgers was actually funded by the NRCC. Early in our history, basically, for those of you that are up on politics and the workings of the US government, we were funded through an earmark from Congress. So basically each year we'd go to Congress and money would be added into the federal budget to support the RCCs. But basically as time went on through the 90s, earmarks went out of the federal budget, and actually the services we were doing to NOAA, we became a line item in the NOAA budget and have kind of really been there through the late 1990s up until the present. Like I said, we're competed in 5-year contracts. So the Northeast was just awarded. So we have another 5 years of doing the services we provide. I think it's up to you, Jess.
All right, thanks, Art. So I'm Jessica Spaccio, and I'm going to kind of get into the meat of the presentation.
Jess, you're
here.
muted.
I am. It says
No,
I'm
we
not.
can hear.
Oh, you're
great.
fine.
Okay,
we can hear
thanks.
you.
So our first kind of group of slides here I have are on our outreach and collaboration. And so what I mean by outreach here is really the products that we put out for our stakeholders and our partners, and to some extent the public and the media as well. One of those that we do are our quarterly outlooks. So those are put out at the end of each season, the 3-month climatological season. So we just put out our winter one was done in March. And we do these actually for three complete separate outlooks. We have one for the Eastern region, which covers our part of the kind of the Northeast here. We also do one with the Great Lakes region. So we partner with the Midwest Climate Center and cover that section. And we also do one for the Gulf of Maine, and there we partner with Environment Canada. So these have kind of evolved. They started as kind of these 2-pagers on our website, and now there's so much content that goes into these. These have actually expanded 3 to 4 pages, and these are found online on our website as well as our partners' websites, and they're sent out to our serves. They have 4 parts, each of them. They all start with this kind of significant events at the beginning, covering what happened over the last 3 months. These could be, big storms, or maybe their lake levels were high, record high. So big things that were going on in these regions. The second section is the regional climate overview. So that talks about what specifically was going on with the temperatures and the precipitation. Was it a wet season? Was it a dry season? Was there any drought going on? So we talk about that. The third section is the regional impacts and updates. So that really delves more into those significant impacts that were kind of highlighted at the top, and gives us more space to talk about other events that happened and more of the impacts. Were there infrastructure damages? Was there power outages? Things like that happened with these large storms across the regions. And then the final section is the outlook. So that'll cover the next season looking ahead. So what the temperature and precipitation are expected to be. Is there going to be a La Nina or an El Nino? What's that looking like? In the spring, we do a flood outlook, put those on there. So these are really a great product. Lots of coordination goes in with these. Like I said, working with other parts of the country and working across the border as well, to get all this information in and get these great products out to our stakeholders. This is just another look at the Gulf of Maine. This one is, they're all a little bit unique, as each region has their own important things going on. So here, like I said, we get to partner with Environment Canada. And so like this map here is showing the winter percent of normal. So we bring in the raw data and we combine that with the US data, and we're able to put it all on one nice cohesive map together. And there, obviously this is covering the Gulf of Maine. So ocean is a big one in here. So there's always a map on the sea surface temperatures, and we're watching that and monitoring what's going on there. Here's a little bit of the text that was talking about the ice coverage on the Gulf of St. Lawrence. So each one is a little bit unique. We also partner with the Mid-Atlantic RISA, and they do an outlook as well. This one, again, has a little bit different flair to it. They host this on their website, and this is a little bit more interactive than the other ones that we publish. But we partner with them, giving them kind of some of the same things, what big events happen, to make sure that that's in there. We also make the maps for them. So here's an example of the map that covers the Chesapeake Bay. We've got the outline of the watershed in there. So we create those maps. And then we also work with them. They have these really nice interactive portions on their outlooks. And they're different each season that these are put out. It'll kind of go over something different. Sometimes we're sending data that goes into these, and sometimes they're pulling something in, like hurricane tracks that they did in the fall. We also put out some special reports depending on what's going on. So July 2016. So that was when we had a really big drought here in the Northeast in 2016-17. So we put out a nice 2-pager on that with some information to kind of give a recap of that to everyone. And then in the fall, just this past fall 2020, when we were monitoring La Nina and what that was going to mean for our winter, we kind of put out an information, another 2-pager there. What does La Nina mean? What are some different winters under different La Nina scenarios? So we try to get that information out to folks. Webinars. So we also have our own monthly webinar series that we do as well. It's a NOAA Eastern Region webinar series. So we partner with the NOAA Eastern Region Director, and we put these together every month. We've been doing these for several years, I think maybe close to a decade by now. And these we've gotten great feedback from. We put out a survey at the end, and people have been pretty responsive to that. So each month it covers kind of the month in review from the end of the month. And notice we have a dues discussion. I'll get into more what a dues is, but it's a drought discussion. And then we have a special speaker. So we cover something different every month. This past one that we just had at the end of April was the Northeast Climate Integration Modeling. And then the one we're having at the end of May is going to cover the updated climate normals. So we have great topics each month, and those you can sign up for, and we have those planned for a good part of the year ahead. We also get quite a few attendees, usually 50. We've gotten close to 100 before, and it's really a broad audience too. We have a lot of our state agencies, some municipalities and state planners will join as well as our federal partners, and sometimes a few media folks. So now I'm going to get into kind of our ACIS interfaces and products. So ACIS is something that we'll talk a lot about. Some of you may have heard of it. Some of you may have not. Some of you may have heard of it, but not really sure what it is. So what it stands for is the Applied Climate Information System. And so basically, Art had mentioned there's, NOAA has a lot of data. There's all these data resources, but if you're not, a data scientist, you may not be able to access it easily and get the data in the format you need, or figure out what kind of data you need for your project. So ACIS kind of takes that data in and makes it usable. So this slide is really showing the different data sets that come into ACIS. So there's a lot of things coming in. We have graded data from different data sets. PRISM is one. We've got the daily LIVNA data, and then our 5-kilometer graded station data as well. We have model data in there as well from LOCA, and the different models and different RCPs and the different global climate projections. We also have the historical and real-time station observations. So the Global Historical Climate Network that comes from NCI and through their daily climate station data. We have some Mesonet data from New York State and some other, I think, surrounding states as well, possibly. And then we have our hourly automated stations. Those are primarily airport data that take those hourly data. And I should mention that these historical and real-time observations are really real-time. They come in multiple times a day. And if we're looking for hourly data, you'll have the previous hour's data will be in there. So data really is up to date. And then we have some data coming soon. So we're looking for some data from projections for Alaska and some short-term forecast data available, which we get some requests for. So it'd be nice to be updating that. And so so that's what goes into ACIS. What comes out of ACIS is we have all of these different interfaces. So I'll be going through the next slides explaining what these are, and we've kind of nicknamed them like Ag ACIS is for our Ag community, and all these different ways to actually access the data. So the first one I'm going to talk about is SC-ACIS. This was originally created for the state climatologists, so SC standing for state climes. And so it was kind of, we asked them, what kind of products they needed in here and what kind of reports they needed, and that's where this came out of. So I'm going to do a quick demo of a couple of products that we have in there. So you should be able to see my browser here. And so when you bring up SC-ACIS, this is what you'll see at first. And there's really a ton of different products that are available in here. And I'm just going to have time to show you a few. And I'll go through our other interfaces as well. And if you find that there's something that you're looking for, it's always best really to either have time to play around with it or just to contact us and say, hey, this is what I'm looking for. Which report do I need? How do I access this data? And that's really what the RCC is here for, is helping people get the data they need. So here there's several different kinds of products. We've got our single station products. multi-gridded, and then some other things. I'll start with the single station products. One of the things I wanted to show was the normals. So yesterday, the new normals were released. So they're updated every decade. So we were previously using the 1981 through 2010. And as of yesterday, we're using the 1991 through 2020. And that's already updated in ACIS. So we have that live. So I clicked on that product. And then we have some output selections. We have a graph, table. If you'd rather have a CSV list, you can check that. Monthly or daily, month range. The variable default is temp and precip, but we also have snowfall, heating, cooling, growing degree days available as well. Stick with the default. I do a search for Philly. You can put in the ID if you know a station ID. Lots of folks don't. So you can just do a search, and then it brings up basically a Google map and also a drop-down list with the stations from proximity. So we take a look at the Philadelphia airport. So you can see how quick and responsive the website is. It creates a nice bar graph here. You see it does have the new normals updated 1991 through 2020. So we have the bar graph showing, got the precipitation normals and then the max and min temperatures overlaid as well. And down here is the graph. So we can see annual precipitation under the new normals for Philly is 44 inches, max temperature is 65. Also pretty cool, most of the graphs that we have on here is an export option. So if you want to download as a PNG or JPEG, PDF or SVG or print, we have those options there. So it's really easy if you are doing a presentation yourself, you can pull these out and use that. Another product that I want to show is our accumulation graph. That one is really interesting, especially when monitoring drought conditions. So this automatically has the start date as the beginning of the year and the end date is today, depending on what time you're logging in, it may show the previous day. And there's different options, precip, snowfall, or degree days. We'll stick with precip. And you can put different lines on the graph. Normal, I'm also going to check the highest and lowest. If you wanted to include other years, you could have it put up other years. And we'll just stick with Philly. I've got that selected already. So again, really quick, it brings it up. So this green line is showing what the precipitation is this year is the 2021 precip accumulation. So how much we've had since January 1st. So we've had 13.20 is what we had so far. Normal is the brown line, and it's just a little bit. So just a little on the low side, but not bad. Here at Philly, normal is 13.82. And then you've got the wettest year was in 1979 and the driest year in 1992. And that's just through May 5th. And again, you can download the PNG or JPEG or PDF. So that's pretty handy. I'm going to show one more thing. There's so many things to show in here. The gridded data products are really cool. We can go into maps and you can make a map really quickly. You've got daily, monthly, or different intervals. I'll just stick with a month to show you quickly. Let's say you want to look at, we'll look at precip again. There are different gridded data sets, and you can hover over the little eye for more information on which one you want. And I've got New Jersey selected, click go, and pretty quickly here we've got a really nice map showing gridded precipitation for New Jersey for the month of April. Okay, so those are a few things. Like I said, there's lots of options there, but just to highlight a few of them. Get back to the presentation here. Another interface that we have is ACIS, and all of these are just slightly different, catered for different users. So this one was built for the National Weather Service. It's very similar to ACIS. This one doesn't have the cool gridded map that I just had showed, but it does have a lot of similar products. This example here is showing consecutive days. We want to say consecutive days with snow depth of 50 inches or more and what those dates were. There's really a lot of awesome reports. You can really delve down and get some cool data from these. Now data, this is something that's used on the National Weather Service websites across the country. So any National Weather Service CWA current warning area that you go to, they will have this now data page on their site. So this is, again, like Art said, even though we're the Northeast, these are products that are used nationally. So this has some of the same reports that you can get on the other ACIS pages. Again, these are kind of tailored for what someone might be looking for when they're on the Weather Service site. So again, this is kind of a public facing site. ACIS is for the agricultural community. This was actually done specifically for NRCS, the Natural Resources Conservation Service. So again, tailored more for them. There's some frost information, different growth information, and these kind of reports that show up nicely for them. Here we're showing soil moisture data. So this is, these are scan sites and also tribal scan sites. And this is interesting because not many of our normal data sites that we pull data in take soil moisture, but these sites do have that. So it's another interface, another way to access that data that isn't collected at many other stations. So you can see there's, not a whole lot of sites, but there are a few out there in our specific region here. But you can access these sites and you can get these cool reports showing the soil moisture and water deficits. This is a screenshot from one of the, our pages on our website. So we have a lot of information right from our website without having to go out to these different interfaces like XMACIS or ACIS. This one is showing the state averages. So you can click on a state and figure out what the average temperature or precipitation or maybe what max temperatures were for any month. And then it also creates this nice graph at the bottom. You can see departures and you can export the graph. Up next, I have I can click. Here we go. Some wind roses, and I'm going to again go to the website so you can see these live. So wind roses are just basically a way to look at an easy picture of how the wind, both direction and let's put in Baltimore, and that you can kind of play around with how you want this to look. So we can go by percent or total counts. I'll leave it as percent. 36 point compass, I recommend leaving that. You can change the wind speed. And these are the different bins. I'll kind of show you what this looks like first, and then that may make more sense. Let's do a start date. Let's do the beginning of the year, or maybe we'll do all of 2020. And then we click go. Let's try that again. User error, I'm sure. Let's see. Let's do.
You have the wrong ICAO.
Did I
Yeah.
have the wrong ID? I was figuring that was probably what I had done. There we go. And so really quickly that pulled up the 2020 for Philadelphia Airport. So this windrows is the graphical form of that is showing the percent of time that the wind is coming from the different directions. So you can see there's usually a southwest wind. So the direction is coming from the southwest. It has all the different bins. So these are the bins that you can change on the previous page. And then it also gives you a nice table of what those frequencies are. And then there's great export options. So you can export those. And you can play around with this too. Like if you wanted to just look at Januaries for the past 10 years, you could edit this section to just be Januaries and you can say what typically direction is a January wind. So that can be really helpful for certain applications. We also have some climate gauges. I want to show you these on our website too. So Central Park is what it is, the station that it defaults to. And there's really a lot of stuff on this page. The first set are for temperatures. And so this is showing May to date. And what this means is this is the average temperature from May 1st to May 5th, or it'll be 4th through yesterday through May 4th. And so we will only have a few days since we're at the beginning of the month, but it's showing that this temperature is slightly above. So it might be a little more interesting if we look at spring to date. And with this temperature, it's quite above normal. That's why the red is larger, where here the yellow is larger. And you can actually click on this and you'll see that gauge again. And you also see the time series. So you can see the average temperature for spring today is 47, but this year it's been 50. So that means we're above the 75th percent, and that's why the red is highlighted here. And it's a pretty cool time series. You can see that those temperatures seem to be increasing fairly. Pretty good trend there. There's also year to date. So same thing, temperatures year to date, and those are above normal as well. We have the same thing for precipitation. And here this time I'll look at the year. So this year there's been 14.35 inches. Average is a little bit more than that, so a little bit on the low side. And then the last three, these change a little bit depending on the season. So right now it's looking at days above 90, and there haven't been any yet. We're only into May, but you can also change this. So let's maybe look at days above 80. So I click that and it changes. There's been 3 days and it's actually above normal. So typically there's only one. This year there's been 3. So it's pretty neat. You can also change nights above 65, and then you can change this along the bottom if you want to see nights above 70. And then rainfall, if you want to look at big rainfall events, over an inch, there's been 2, but let's say if you want to know how many 2-inch events, there hasn't been any yet this year, but you can see how it has looked in other years. So another cool product that we've put out, and you can look at different stations. If you click on the stations, you'll see where these are available for. So if you want to look at Atlantic City, you can see they generate pretty quickly, and all that data is right there, and it's nice visual representation. So I'll go back to our slides. So those are the wind roses, the gauges I just showed you live. So I'd be remiss to not show some of the mapping products that we do. I know we showed a lot of kind of reports, but we have a lot of mapping products right on our website as well. You can get them for the region, you can get them for states. We also, the High Plains uses the ACIS data to create their maps that we show on our site as well. And we've got, temperature maps, precip maps, departure maps. So snowfall departure, that meaning departure from normal. So we have a lot of map products as well. And with that, I will let Art go. I'll stop sharing so you can bring up yours, Art.
Oops. Just got to get in the slideshow mode and I should be good to go. All right, that went off kind of without a hitch. So really, I want to shift gears, and we're still going to see a lot of data products, but actually kind of more aligned with in the products that I'm going to talk about, work we've done with specific users to develop products that meet their needs. And really, in a lot of these cases, what the products do is blend together a bunch of the different data sets that are in ACIS. So in the first one, I'll use kind of a New York example. This is actually work we are doing with NYSERDA and the Public Service Administration in New York. And basically what they do here is monitor, at least in the winter season, heating degree days. And they basically do that to look at reports or supply of heating fuels and things along those lines. So again, what we've been asked to do specifically by the group is look at a set of cities in New York, and then basically they're looking for this on a weekly basis. So what we're showing here is, this was something that might have been run back in October of I guess it was 2019 in my slide here. So what they're asking for showing is in that week, what's the normal accumulation of degree days? What is it in the current year? What was it in the last year? And again, they use this to manage their supplies and what to expect and things like that. So it's a week to date product. It's a month to date product. And then where it blends a different data set is they're also looking for a forecast. So they're looking the next week out. So that's where instead of looking at the observed data at these stations, we'd be bringing in forecasts from the National Digital Forecast Database. This is a project that actually has expanded quite a bit. It started in Maine, And right now we're doing products for New Hampshire, Michigan, Wisconsin, and also North Dakota. And what basically the output is from this series of maps is an index of road freezing. And to kind of give you why the heck are we concerned with road freezing? Well, in northern tier states, what is done in the wintertime is the states allow trucks to carry heavier loads because the roads are able to support more weight since they're frozen. So basically, sometime as you move into winter, the state enacts these what they call as weight premiums. So they have to let the trucking companies know that they can increase their loads. But more importantly, as we move into spring, they have to remove those premiums. And basically, that's where the big money comes into play in this case. Because if the trucks are carrying heavy loads on roads that are starting to thaw, it causes substantial damage to the road system. So they have to remove these premiums before the roads actually thaw, and they have to give the trucking companies enough notice to say that they have to reduce their loads. So basically, we've worked with the states. They have an equation to determine when the roads freeze or not. That's loosely related to temperature. And then basically what we worked with in each of these states is kind of a design of the map that they wanted. So, if you look at the map here of the thawing index here in Maine from last year, not my choice of colors basically, but their choice of colors because they really wanted to highlight the areas where they had to act upon. So, to the level of detail of that basically, we collaborated with them in the design of these projects. It's up on our website. It's updated each day. As you can see, maybe over here to the right, these are maps for one day, but you can look at the forecasts again from the National Digital Forecast Database out for a 7-day period. Again, so if they're looking maybe, I think there's going to be thawing the end of this week. They might want to reduce the premiums based on the forecast in this case. And just kind of as a way of looking at the economic value for this, basically each mile of road in Maine, if they were to repair the winter damage due to heavy loads when the roads are thawed, each mile of road would be a savings of $300,000. So across the state, quite a bit of savings there. And again, by working with the DOTs in Maine, this is how this product kind of moved across the northern part of the country to the states that enact these premiums. We do a lot of other monitoring for agriculture. So at this time of year in upstate New York, the big question is there going to be freeze damage to the apples? So the apple trees, at least this year, these are some older maps, are in full bloom. So one part of the monitoring status is what is the status of the apple trees on a given date, and that's basically a temperature-derived index. But then more importantly, going into the future, it would say if the apples are in a certain phenological phase on today, what is the chance that they will experience a killing frost for the rest of the season? So in this case, if we're looking at apples that are currently in this stage on this date, the probability of a killing frost is pretty low in the Finger Lakes. If for whatever reason you are an apple grower in northern Maine, you should probably get a different job, but obviously the risk of freeze would be a lot higher up there. So this is something that the ag community across New York and New England is really looking at right now, because apple trees are at a very vulnerable stage, and exactly where this front that's kind of sitting us is setting over could put them into some trouble in the rest of the week here. I think several of the folks on the webinar are familiar with our work with extreme rainfall. And kind of what I want to do with these graphs is kind of show a whole progression of this project. So basically, several years ago now, we were asked by the state of New York through NYSERDA to basically give them some indication on how extreme rainfall will change in the future. They wanted to use this information in kind of setting policy, looking at design standards across the state think I saw Alan's name on the participants list. New York City has looked at this. And basically in the engineering design community, a product like this graph that's shown on the right, an intensity duration frequency curve is used. And it's basically how the engineering community determines the risk of extreme rainfall. So you might say, all right, if I'm looking at a storm that has a 1% chance of occurring each year, the 100-year storm, that's typically based on, or that is based on historical data. But what New York wanted to do, and particularly the New York DOT wanted to know, is with climate change, what would that value look like, 50 years from now at the end of the century? So we worked closely with them to basically do the research, to collect the model from downscaled climate data, and to develop these products. Since then, again, another partnership with the RISA to the south, working with Marisa, I'm kind of asked to do the same thing for locations within the Chesapeake Bay watershed. So the graphic is kind of covering up the map. So basically working with the Marisa folks and also a group at Carnegie Mellon University in Pittsburgh, we looked at some different models than we used in New York, basically a more extensive data set, but did a similar analysis for stations within the Chesapeake Bay watershed. So if you can kind of squint your eyes and maybe look at a little bit of what you can see up there in New York, the stations are within the watershed, within the Chesapeake Bay watershed. And also, again, from some existing funds, the Chesapeake watershed doesn't cover the entire state of Virginia, but the state of Virginia has also contributed some funds. So we did all of the state of Virginia as well. Where this varies a little bit differently from what we've done in New York is we've really tied this to stations that are in NOAA Atlas 14. So in the New York case, we were kind of looking at our own historical data, but in this case, we really tied our adjustments for the future periods in these IDF curves to the values that are published in Atlas 14. So a user would be able to say, I guess I was going to do a demo here, but looking at the time, I'm going to skip that. Actually, maybe I can do that real quick. Go to my browser. Might be a better way to do it.
You've got plenty of time, just so you know.
Okay, thank you, Franco. You can see my browser. So this is the website live. We've chosen, get a little more interesting thing, end of the century high emission scenario. So you can change the period of time and the return period and the emission scenario that you're looking at. Basically, what we've done is downscaled what we're calling change factors to a county level. So each of the counties on this map have a different adjustment factor. So unfortunately, Philly is not in the watershed. So if I'm looking at, say, Carroll County in Maryland, what that's showing is if we're looking in a high emission scenario, RCP 8.5 at the end of the century, in Carroll County on average or on median, basically the Atlas 14 value for the 100-year storm should be inflated by 18%. So the change factor is 1.18. We also give a distribution of change factors, and that distribution is across about 50 models that we looked at. And I guess I should say, I kind of lied there. 30 models using one downscaling technique, 20 models using a second downscaling technique, and then also a number of random realizations of those model selections. So really those percentiles are based on many thousands of things in the sample between the models and the random resampling. So again, what this would say is the adjustment factor for Carroll County should be 1.18. But if we look at the spread of the models, basically 50% of the outcomes are somewhere between a 4% increase at the 25th percentile or a 38% increase at the 75th, and then taking it out further to the deciles. So Again, a lot of uncertainty here, 50 years out into the future with 100-year storm. So some of the model combinations do suggest, or a small percentage of the model combinations suggest a decrease in extreme rainfall for that county. But like we can see here, over 75% of the models are showing substantial increases in that case. I can click on a station. So we'll pick on something in Wilkes-Barre. And again, what that's doing is it's grabbing the data from Atlas 14. So the Atlas 14 IDF curve is shown here in red. The projections for this high RCP at the end of the century are shown in the shades of blue, the median shown by the blue line, the quartile range shown by the darker blue shading, and the 10 to 90% range shown by the lighter shading. So you can see the quartile range is really tight around the median, whereas the outliers are a bit further across. You can shut that off if you want and just see the medians. You can turn on the Atlas 14 confidence intervals to kind of show there is some overlap between the two. Like Jessica showed in the other products, you can download the graphic if you want as a ping. You can look at this as a tabular form. So basically the change factors are being given. And then for the different durations of rainfall from 5-minute to hourly into the one-day storm, basically we're showing the projected depth of rainfall. So basically here, we're taking these change factors and multiplying them by the Atlas 14 value to get the actual rainfall value instead of the values in inches. And then the chart can be downloaded as a CSF. That was, again, we've worked with the stakeholders in this case, the Bay program in the state of Virginia, to kind of design this to their need. They wanted things on a county scale. So that drove how we were interpolating our data, and a lot of the different graphical and tabular formats were what they felt they needed to do the things that they needed to do. So I can go back to my PowerPoint. Did that make a clean change back there, I'm assuming?
Yep.
Yeah. I should also mention that we're also doing similar work for the state of New Jersey. So we're kind of eventually getting a good part of the Northeast with similar things. And I would say definitely a very, very analogous methodology between the Chesapeake and New Jersey. Basically, I would say an improvement in our methods that we started off with in New York. So hopefully we can talk to the New York folks and get them interested in coming into line with the states to their south. And also that might be something, should mention with a lot of our data sets right now. Jessica mentioned data sets that we're spinning in terms of projected data. It's really LOCA data that go into this. Hopefully in the coming year, when there's downscale data from the CMIT-6 models, the new generation of climate models, that will be in there and be able to be incorporated into many of our products. Same type of work, kind of an offshoot of work that we did for New York, and we're actually continuing to work as kind of a side project. And the idea here is really monitoring changes in extreme rainfall as time goes on. So if you're sitting in Philadelphia or New Jersey or points south, the last data that went into something like Atlas 14 for the Mid-Atlantic region was collected in the year 2000. So basically the premise for a product like this would be to say, as time has gone on and we've added 20 more years of data, how has that new data affected the values that are tabulated in the static atlas that NOAA puts out? Being in New York and being kind of outside of the urban corridor, a lot of our products are ag-based. And here is where in our climate data system, we really start to pull in data, not necessarily from NOAA sources, but from a lot of kind of state and regional mesonets. So The map on the right kind of gives you a flavor for the little green dots are weather stations that kind of bunch together at this resolution. But you can see quite a few of them in New Jersey and Delaware, a fair number up into Connecticut and in Massachusetts, a good number in really the fruit belts of upstate New York and also Michigan, and also Wisconsin along the lakes. And if this map went further out, we're collecting mesonets from states as far west as actually Utah and Idaho. Most of the work here, again, given our location in upstate New York, deals with apples and grapes. So a lot of where the stations are in this case, or the data we pull into this, are in apple growing regions, since that's a lot of our models. And really here we're using real-time data, both in a forecast mode and sort of the very recent past, to allow farmers to make decisions on how they're going to manage their crops, basically spraying for different diseases and different insects. And again, one of the things we try to do with any of our products, it really keeps NOAA happy and also our supporters in Congress, is try to put a dollar value on our products. So we do a lot of surveying work. The ag community tends to be an easy group to kind of get a dollar value for. So in this case, we're looking at spraying for an important apple disease, apple scab. If you ever gotten an apple from maybe a roadside orchard and it kind of has exactly what it sounds like, kind of a scab on its nice bright red skin, that's what they're trying to prevent. It's a fungus that causes that. And here, if we can save a user basically one spray out of the year, you can see the savings of the cost. So on the average farm in New York, one spray is about $20,000 a year. And if we kind of just in the spraying costs, and that's about that's about 10 times more of a savings in crop loss. So you kind of have two things. You need to spray to prevent the crop loss. So you want to make sure you're spraying at the right times to have a more valuable crop, but also not waste your money on an unnecessary spray. Basically, the NUA website that does these tools is in the midst of a major rewrite to make it mobile friendly, to make it responsive, to add a lot more data sets and things like that. So that's something that's actually kind of being slowly released right now as new models are being added. So the new site is out there. And again, typically, definitely lots of meetings, lots of feedbacks from the users in terms of the types of tools and the way they want their data presented. Kind of along the same lines, a lot of these ag tools have kind of actually run the gamut. So this is a tool we call, or is called, Adapt-N. It was basically a tool that we were running on our website. And really the crux of this tool is for basically nitrogen fertilizer management. So basically, if I'm a corn farmer in New York or even Iowa in this case, it basically is telling me how much fertilizer do I have to apply to my crop to maximize yield and minimize environmental consequences. So basically, the gist here is it's really rainfall. So the idea is coming into the growing season like this time of year, if the winter and the early spring has been fairly dry, there's actually a substantial amount of nitrogen left in the soil. So really in a dry spring, there's not much need to apply extra nitrogen fertilizer. And so we can monitor the weather conditions. We've worked with agronomists on this tool. And basically the idea is a maximization problem. You know, what's the minimum amount of nitrogen I have to apply to my crop given the current weather conditions to maximize my yield? We can, again, do the math on this. And basically the savings in this is immense, basically. Just in the state of New York on the acreage of corn, by using this tool, kind of the estimate there by our ag economists were $20 million a year in profits to the farm. So again, it's not unnecessarily putting down nitrogen and basically maximizing yield. What that doesn't take into account is the environmental benefits. So basically, in a very wet spring, you might not want to put down a lot of nitrogen because it's only going to wash down the waterways and enter the Chesapeake or enter the Gulf of Mexico and contribute to harmful algal blooms in hypoxia zones. So really, another component of this tool is exactly that, to mitigate the environmental losses. Again, applying the nitrogen unnecessarily also adds to greenhouse gases through N2O. So really, this tool has gotten picked up by a lot of the big corn growing outfits, like namely Walmart and places like that. And they tout this as one of their environmental tools. So if you're a grower for a supplier for Walmart for basically corn syrup, and you want to have their stamp of approval for being environmentally friendly, using this tool is one of the things that you can claim that counts toward you. Since the time that we developed this tool, it's actually been commercialized. It was commercialized kind of very locally by a group in the US, and that's where it spread to being used on a lot of the acreage of corn in Iowa and Illinois. And since then, that group has gotten bought out by a big international agricultural firm, Yara International. So they are basically using this tool in a lot of their software, basically tying it right into GPS systems and tractors and things like that to use the weather data that we still provide to make this management decision on farms. One of the good things about, I think the good things, I guess I'm a little biased, is about the climate centers is we tend to be very nimble. So unlike, say, an agency like NOAA. So a while back, we were approached actually by some water utilities in the suburbs of New York City, looking to increase water conservation in the summer. So basically their demand for water in the summer was pretty much higher than they could supply with their current infrastructure. But they realized a majority of this usage from their use patterns was suburban lawn watering. So they really wanted to institute a program to kind of inform people when they should be shutting off their sprinkler systems and when they should be using them. So we developed actually an app for them that monitored both rainfall, allowed a user to kind of specify the type of sprinkler system that they were using, and also monitored evaporation. So we could have a kind of a mini water budget in a suburban lawn, and then make a recommendation for if a person needed to water today or not. And kind of taking that also to the extreme, we also brought in the kind of really near-term forecasts. So in a case where, yeah, maybe you should have watered today, but there's an inch of rain forecasted to occur tonight or tomorrow, that forecast would enter into the recommendation in this app. Jessica mentioned earlier our drought monitoring capabilities. So boy, following the drought that affected New England, mainly the Boston area in 2016, and also parts of upstate New York, a national group that's called NIDIS, they're out of NOAA, it's the National Integrated Drought Information System, basically started to take notice of the Northeast. The NIDIS had primarily been a Western US, Midwestern US entity until 2016, when some very major drought conditions hit the Boston area, something that hadn't been seen in about 20 years. So basically, they spurred again at the federal level by Congress, the congressman from the Boston area said, hey, what are you doing for the Boston area in terms of drought? And to be honest, they weren't doing much. Hopefully nobody from NIDIS is on the call right now, but we were at the NRCC. So that actually was the start of a relationship with NIDIS in the Northeast that has grown since then. So NIDIS supports these things they call DEWSs. They're called, the acronym is Drought Early Warning Systems. And basically they're meant to monitor climate conditions and really work with stakeholders to get the right data, the right conditions to kind of meet their needs. So lots of stakeholder engagement. When, if you guys can remember, we were able to meet in groups like that and actually have conversations other than on Zoom. And really from there, we've developed a dashboard for NITIS. We have a group of people that basically confer weekly for input into the National Drought Monitor for the Northeast. That was a big contentious issue during the drought of 2016, because really the drought monitor, and when the drought monitor turns red, that actually is the trigger for a number of drought relief efforts on the federal level. So basically, kind of if you're looking for federal resources, you want your area to be in the red during a drought. But obviously there needs to be an independent body that kind of dictates what gets put into what drought category. And that's where this group really comes together and has a lot of give and take, a lot of on the ground information that goes that supplements the more objective indices that go into the drought monitor. And since then, we've started to work, or we are working very, very closely with the state of Massachusetts themselves. So Massachusetts kind of does their own thing in terms of issuing drought warnings and drought emergencies and things like that. They have their own monitoring protocols. So we've been actually able to work very closely with them to increase the amount of data that they have across the state in their products, and also to really automate a lot of the things that they do. It used to be that they get what data they have from the stations they have, and somebody would work with a spreadsheet and kind of come up with these things at the end of the month. And pretty much as of a couple of days ago, Jessica, we have this down to it's not even a push of the button. It's a cron job that works here on our system, and the data are transferred to them. I guess this is a segue and a little cognizant of the time. So what I want to say is what we've really shown up until this point has been kind of the products and the web interfaces that we have developed for people. But behind all of that is a really neat infrastructure that ACIS is, that allows any user really access to that data. So there are what are called web services, APIs, application programming interfaces, that really allow anybody to go into our database and make requests for the types of data that they would want in their application. So there are a number of partners, and unfortunately, many of which that we don't even know about, since the interface is open and available to anybody who use the interface. A couple of examples here from different groups, a number of different federal agencies, the Forest Service, basically, or the National Park Service does climate assessments for each of the parks that they link directly to ACIS. A lot of the climate graphics that Climate Central might put out are basically coming directly from ACIS. Their programmers hit our interfaces quite often. So I kind of do want to spend the last couple of minutes that I have at least talking about the interfaces, and basically what it is. It's a way to allow data users to basically harness the power of the metadata, the data sets that we have, and the software that we have within ACIS. And I'm going to step through just a couple of examples. And yes, it's code, so I'm kind of tailoring to the data geeks here. But basically, just as an example, I'm making a simple request to my database. I'm doing this actually from the browser interface. So I'm making an HTTP request from a browser, and I'm saying, hey, I want data from a station. I happen to know the station ID, and it's Ithaca. And I want data for basically the year 2012. And what I want, my elements here is I want the coldest minimum temperature in each of the months. during this year. So a little bit of knowledge, and there's documentation to kind of get the syntax down. But if I enter that request into the browser, basically this is the return that I would get, and fairly quickly. I think you saw some of the returns. Any of the requests that Jess was doing live with ACIS is exactly that. It's making a request like this and going to the database. And basically, I'm getting a return structure that in each month in 2012, what the coldest temperature was in Ithaca. And you can get quite, there's a lot of power to these kinds of requests. So in an example here, I'm looking at, my station is Minneapolis. I'm looking at a series of years. And basically what I want to know is in each year, what was the last occurrence of a temperature less than or equal to 28 degrees Fahrenheit. So, I know the syntax. I can go to the documentation and get the syntax. And then my report is, okay, in each of these years in my series of record, this was the lowest, this was the temperature that was lower than 28 degrees. And that was the day that it occurred on. So in this case, a balmy April 12th had a temperature of 17 in Minneapolis. You do the same thing with map products. So here I'm looking at an example, right? We have access to the gridded data. So in this case, I'm asking the interface kind of, I'm doing it now in a programming interface as opposed to, this is maybe within a Python program or JavaScript program, where I'm asking the interface, I want gridded data. I want to look at the state of Nebraska. I want to look at the June of 2012. And I want to know what was the maximum temperature in June of 2012. So it looks at all the grids in Nebraska. It finds what was the maximum of the maximum temperatures at each grid in any day in June. And it telling the interface, I want my output to be an image. And I can set the projection of my image. I can tell the image what I want overlaid on it. So I want the state outline and the county outlines. Do I want to smooth or interpolate the data? And I'm saying, yes, I want to do it with a cubic spline. And I can set my contour levels. So basically, this was a warm June in Nebraska. So I'm contouring the data at 90, 95, 100, up to 110. Basically hit go. And my output is a number of different levels. So some information on what levels I've asked for, what the bounding box is, what the actual range of data is, what colors correspond to these contour levels, and then the map itself. So a very, very point that I want to make here is a very, very usable interface, not having us code your website, but using the power of ACIS to basically develop your own products or access data for your own programs and code. We use with our document, we also have products that are hourly from ACIS. So just here's a request for hourly data for Ithaca. This is really what powers a lot of the behind the scenes stuff in our ag products, which rely on hourly data from the Mesonet stations. With the gridded data services, one of the other key things that I mentioned is there is also a function that can be applied to provide an aerial reduction. So basically, in this case, in the request that I'm asking for here, I'm saying for this particular winter, I want to know, based on the gridded data, what was the lowest temperature in each county in Vermont. So I don't care about each individual point, but I want the interface to look at each county, find what grids fall within that county, and give me back the minimum. So in this example, for this December in 2011, the 33005 is the county ID number. It's a FIPS ID. And in that county, the lowest minimum temperature was -24. In a different county, it was -29. You can average across whole states. You can average across HUCs, which are hydrologic basins. So there's a lot of power here in aggregating the gridded data spatially. We can do map products with the LOCA data are in there, so we can look at maybe seasonal degree days in the future. The data behind ACIS and its gridded data, particularly the projections, it's the data engine behind NOAA's Climate Resiliency Toolkit, Climate Explorer. So we've been working with this group for quite a while, and basically it's our data sets that populate any of the images or tables that you might see in Climate Explorer if you've used that tool. So just some examples of the types of products. So we're looking at gridded data from LOCA, projections out into the future with different scenarios of days above 90 in, looks like I'm doing, looks like New York County, so Manhattan. I could do days with minimum temperatures above 80 for the same county and look at that change through time. So it's not us that's providing the graphics here. It's actually a private company that Climate Explorer has contracted with, but our data sets and our data infrastructure that are the underlying features there. We've also, with the new normals, are working with NOAA for a similar interface for the new normals. The new normals are gridded as well as station-based products, and we're providing the mapping capabilities for that. So I think that's my last slide, and that gives us some time for some questions if there are any.
Wow, that was a lot of information. That was very impressive. Thank you so much for sharing all that with us, both of you. We do have some questions. I'm bubbling over with questions, but I'll control myself. A bunch of questions in the chat. The first one is from Marty Dietz, asking about the new climate normals. There was some debate over new climate normals updating every 10 years versus having a baseline set of data, suggesting 1900 to 1930 as a baseline. Can you speak to NOAA's stance? And if the baseline can be selected in ACIS? I guess that's the connection, is the baseline in ACIS.
Yeah, so kind of two things. Yeah, there is a lot of debate. I mean, I think the 30-year normal that's updated every decade is not a NOAA construct, but it's actually an international construct. It's kind of a World Meteorological Organization construct. What I know, NOAA is doing in their current normals is they're also releasing, I don't think it's being released right now, but to be released soon, is a 15-year normal. So that kind of addresses this idea of having normals that are updated more frequently than each 30 years. So I think there are a lot of applications where that makes more sense. And then along the same lines, particularly with their gridded products, yes, ACIS can be used to develop averages. I guess I should mention two things with normals. The normals are not the raw data averaged for 30 years. One of the things that go into the normals that are just released is an adjustment for station inhomogeneity. So if a station moved, or if a station changed observation times or instrumentation, that's taken into account and the data are adjusted to account for those things. And that is a special homogenized data set that NOAA has that's used for that purpose. So that's the classic normals. Yes, in ACIS, you can go into the data and you could average however you'd like to average, 5 years, 10 years, 15 years, 100 years. So that is definitely a capability of ACIS. And I think even a capability in some of the kind of interface tools that Jessica showed. The other thing is, one of my colleagues at the High Plains Center, what NOAA is doing in the release of these normals is they actually have a data set out with these homogenized data values, and the High Plains Center is developing a tool that will allow that homogenized data to be used to develop any kind of length of average. So that'll be really powerful, and I think address exactly what Marty is asking.
Great, thanks for that. Next is a question, I guess, I mean, Atlas 14, you mentioned that that in our region, for example, those haven't been updated in some time. And this is a question about whether NRCC and other NOAA products are expecting, are potentially covered by the American Jobs Plan if it passes Congress. Is there money allocated to sort of expand your operations?
We sure are trying to do that. Whether it actually is or not, I think a lot of the stuff in that legislation fits very squarely in not only the kinds of things that we do at the RCCs, but also what the REISs do. And being the optimist, I'm kind of poised that I'm optimistic that there's will be a lot of good opportunities to kind of do the things that the climate service community, the RCCs and the REISs do. So we're definitely exploring those types of opportunities. And one way we do that is working with the stakeholders, right? That's what I think at least our friends in Congress really like, the fact that we're providing things to people, and it's the things that people are using in their resiliency planning and things like that.
Yeah, so speaking of resiliency planning, you showed a lot of tools. Most of them seemed like tools for agricultural practices or, in some cases, stormwater management. But there's a question here about whether, from a green building perspective, is there any, have you had any requests to develop any tools that help the construction and building industry?
We've had a few requests, and they've basically been not requests that have kind of I guess, what do I want to say? We've had requests and basically have given people data that kind of are being used for those types of things, but we don't have kind of an operational tool that's kind of more developed for that industry. Working with, working with Marisa and actually CISA and GLISA, we've been doing a little bit more with that group, those groups have been doing a little bit more with getting data to city and regional planners and things like that. So we've been, obviously you know about that, Franco, you've been involved too, so has CC Runs. So we're starting to move in that direction a little bit in terms of in getting some of the mainly projection data to those kinds of groups.
So I'm curious, just sort of following on that, where is the line between a data request and a collaboration on the development of a tool? And does a user who wants to develop a tool, is there a line item in your budget to develop tools with certain stakeholders, or is every tool development sort of self-funded, independent of your core work?
I would say the way our contract with NOAA is structured is there's money in the budget to interact with stakeholders to kind of understand their data needs and start to meet their data needs. So quite often it's that part of the budget where we line up the stakeholders. We might do a very early kind of prototype type tool to kind of get their initial feedback, and then from there kind of build the tool out. So in a lot of the cases, the work we've done with road freezing, the work we're doing with Massachusetts, it's our NOAA budget kind of starts that, but then we're actually, have a separate contract with let's say the state of Virginia for the extreme rainfall stuff to kind of bring that to fruition and work that out. The other piece of that, which I think really sets the climate centers apart from other groups, is once we develop these tools, we got to keep them running, right? Because it's something everybody comes back. So it's really, it's kind of a unique situation, particularly in an academic setting, because it's not pure research, right? So a good part of my budget has to be to maintain my data, maintain my servers that's providing the data, and make sure that's up 24/7. The example I did with the tool that became commercialized with nitrogen fertilizer, they pay us for that data. So that's a data stream that's coming in, but that's a blessing, and it's also a curse, because man, that data feed goes down. I get a text from the guy who's monitoring that say, hey, your data feed's down, because it's big bucks for us when their data feeds are down. So that's that's a weird thing in an academic setting.
Yeah, absolutely. I can appreciate that. Flipping it around, I was looking at the attendees, and I know there are folks who are data collectors. And I know this has come up even in my own lab that, we collect weather data for various purposes. We collect soil moisture data for various purposes. Does NRCC desire that data? In other words, do you intake data from, you showed airports, but are there independent data collectors? That could be cities, that could be universities. Is there a procedure for providing that data to you?
We do. We're kind of selective on that. It depends on who the users are. And so, right, if there is a need for that data for a specific application for a specific user, then yes. Where it gets kind of mucky is, what is what's a nightmare if I have to go to Franco to get this data set that's in this format and somebody else to get this data set that's in another format and things like that. That's not a sustainable model. So many of the data sets that we bring in, there is at least a commonality in where we collect the data in what form. So, in a lot of the ag networks that we work with, they're spread out across the country, but they're basically, most of those weather stations are coming from two providers, two weather station providers who collect the data, and then we have a feed into their feed. So we're not collecting data from 1,000 weather stations, but we're collecting data from two central points that collect the data. So that makes that a lot more of a feasible model.
Got it. And there's another question that came in about collaboration on grants. So I'm assuming you would then sort of talk through some of these things and write proposals together with university researchers.
All the time. Yes. I mean, that's a common everyday occurrence. Yep. Mm-hmm. In some cases as their outreach and broader impacts part of things, but in other cases to actually, do the research, develop the model and things like that. A lot of, just differences in types of data sets, gridded data sets and how we do that. A lot of our gridded work was basic research to look at ways of, for rainfall, for instance, our gridded rainfall product integrates weather stations and radar data. So that's a good example of a collaborative research that we did. And you can hear my dog in the background, probably.
I see no more questions online, so I'll just add a couple of questions my own. Do you have, you mentioned how people can, through web services and APIs, access the data. Is there ways of people getting notifications? Do you have an existing app? Let's say I'm working on some flooding in a city and I'm not living in that city, and I want to know if there was a threshold amount of precipitation, and I want to get a notification on my phone that the day, either a forecast, it's forecasted that I'm going to have more than an inch of rain, or it just happened. Is there an app that does that already?
We don't have an app that does that, but you're about the fifth person that has asked for something that does that. So that is definitely, pardon the pun, on our radar screen. And yeah, we've heard exactly that from a number of people. And it's the way our database structures are set up, that is actually a very easy request to make on an ongoing basis, right? Query the database a couple of times per day and see that, but it's developing the software to send out the alerts. So, I'll use this as an opportunity. That would be something, if that's something that you're interested in or CC Run is interested in, that is definitely something that we're interested in.
Okay, then we'll take that offline.
Yeah.
My last question was, so a lot of the stormwater practitioners use some either EPA SWIM or some proprietary version of SWIM for decision making, right? So and a few years back, I believe it was 2014, perhaps maybe earlier, EPA came out with SWIM-CAT, the climate adjuster tool.
Okay.
That gives you these delta change factors. So you put in a zip code and you get a delta change factor anywhere in the US, continental US, Puerto Rico. But they're old, it's CMIP 3. And just curious if NOAA is having any kind of discussion with EPA about, about updating swim cat so that we could benefit, so that your delta change factors are already built into swim. That would be powerful.
I don't know what the answer, I don't know what the right answer to that is. I know that I think that EPA is kind of doing something on their own. I've had several questions and in meetings with folks from EPA asking questions about how we've been doing things with extreme rainfall and things like that. And I kind of get the impression that they're kind of going, they're doing something on their own. I'll just leave it that way. I don't think, I think NOAA is interested in also doing something, but I don't know, maybe I'm shooting myself in the foot. I think there's some turf war going on between NOAA and EPA. I'll leave it that way.
Interesting.
Yeah, I've heard NOAA mention that they're interested in doing things with projections and extreme rainfall. But that's I haven't heard any definite plans to do something like that. I know the group down at NCEI has done some work. Ken Kunkel and Dave Easterling in that group, I know they're looking at rainfall extremes, but it's for like a DoD type contract or something like that. So I think they're looking specifically at defense installations with those data. Yeah, I agree with you. There's a lot going on, and it's a lot of different stuff going on. So it would be nice to have some coordination and some consistency, because you know as well as I that a lot of people are looking for those types of data in their resiliency planning.
Right. And your delta change factors, I mean, if you happen to be in the Chesapeake Bay watershed, you're really in good luck. But otherwise, it would be great if, I don't know how scalable these methodologies are, if it's a matter of just putting in additional data and you can do the rest of the country, or I'm assuming it's much more complex than that.
Yeah, it's more complex. I don't know how much more complex. I think we've kind of maybe, I wouldn't be comfortable in just taking our methods and using it in a place like Tucson, let's say. But those would be the things that would have to be explored.
Okay. Well, I could keep going, but I don't want to do that. I'm curious if any final comments from either of you, or I'm just going to open it up really quick to I'm looking at the chat and the Q&A. I'm not seeing anything else there. So I guess we'll conclude. Thanks so much. This was so much stuff that both of you presented.
Awesome.
There's a lot to digest here, but fortunately we've recorded the whole thing. It will be posted, and folks can go back and use it as a reference. So yeah. Thanks for doing it.
And you guys should have my email, so don't be afraid to reach out to Jess or I, or just the nrcc@cornell.edu. And particularly if you're looking, don't want to archive your own databases and things like that and make use of a lot of the functionality of ACIS. Let us be the data manager and let you guys have access to the data. That's one of the things that we do, and that's what it's designed for. So if that's appealing, let me know.
Sounds great.
And we have a lot of those reports out there, and there's interfaces. So part of our job, like that, is helping you find what you need. So yeah, do contact us, and we'll help you out.
And yes, I agree with the participant who said, "Go Big Red." It'll be nice to have Ivy League sports coming back in the fall.
Oh, I'm sorry. There was just another comment from my colleague over in Baltimore, Kim Grove, asking if there's a list of the links to all of the products. Is that available anywhere? Because there were a lot of products, but do you have them all indexed somewhere? Is there like a nice manual to your products?
Probably in my bookmarks and Jess's bookmarks, I think, maybe. There is not, but that would be something I think we could put together, Jess. That wouldn't be too bad.
We can do that. Yeah. I mean, several of them, some of those products are directly from our website. We have a nice column of links there, but not all of the different interfaces. So I can definitely put that together and send that off to you all to share.
Awesome.
Yeah, I think that would be great. I mean, I'm guilty of needing data, looking at your website saying, I don't know where to start, and then just sending an email, and you get it right back to me. You're like, it's your fault that I do that because
that's all right. That's what we're here for.
So yeah, that would be great. Well, if you produce that and you want to send it back to us, we can certainly distribute it to everyone who's registered for this session.
Awesome.
Yeah, happy to.
All right. Thanks to both of you.
Thank
All
you for
right.
having us.
Have a
Thank
good
you.
afternoon. Bye-bye.
Bye-bye.